Welcome to cryptography session. In exponentiation, in this way they can able to give a problem. 4 is equivalent to 3 power x mod 7. Find x value. So I may need to find out x value. So if you do 3 power x mod 7, it should give the remainder as 4. So you substituted as x equal to 1, 2, 3, 4 like that. So for x equal to 4, 3 power 4 is 81. 81 mod 7 will give the remainder as 4. So in this way, we want to substitute x value as 1, 2, 3, 4 like that. So if any number is satisfied for solving the answer, that is the final solution. So for the first problem, the x value is 4. And for the second problem, if you substitute 5 power x equal to 1, 5 mod 7 is not equivalent to 6. 5 square 25 mod 7 is not equivalent to 6. 5 cube 125 mod 7 will give the remainder as 6. So the answer for the second one is 3. So in this way also the question will be asked like this. So this is the traditional logarithm. Its corresponding equivalent discrete logarithm should be written like this. So log of x into y can be rewritten as log x base a plus log y base a. In the discrete logarithm, we can use mod operations, mod pi of n. Like that, the discrete logarithm and the factorization problem can be implemented like that. And the next topic is primality testing. So if you want to take a very large integer value and we want to check the number is prime or not, it is a most challenging job in a number theory. And also this prime number concept is mostly used in a public key encryption algorithm. So there is a need of standardized method for finding the primality. So there are two types of algorithms are possible. One is deterministic algorithm and the second method is probabilistic algorithm. The difference is in a deterministic algorithm, it always gives a correct answer, but it is less efficient one. If you go for a probabilistic algorithm, the answer is correct most of the time and it is more efficient. The generalized method is divisibility algorithm. So if you want to find out a number is prime or not, we should divide from 2 onwards. First we should divide that number by 2, then 3, 4 like that. So the loop will continue up to n minus 1, otherwise we stop at square root of n. So this notation is a divisibility algorithm. In a probabilistic way, one of the important method is called Miller-Robinson tech. So let us discuss the tech in a consecutive time. So this is the standardized way of doing prime number calculation. It is the oldest method and the probabilistic method is like that. So we already know that mod n means we may directly apply Fermat's theorem for exponentiation notations. This is the square root test, and the most important probabilistic algorithm is a Miller-Robinson algorithm. So if you want to find out n is prime or not, so this is my question. If n is prime, if you assume that n is prime, n minus 1 should be an even number. So if it is an even number, it is always in powers of 2. So m into 2 power k is the generalized way of writing n minus 1. So if I am writing a to the power n minus 1, this power value can be rewritten as a to the power, instead of n minus 1, I am substituting the value as m into 2 power k. Then if it is a of m into n, this will be rewritten as a to the power m whole power n. So instead of n value, 2 power k is available. So a power m value should be used 2 power k times. So 2 power k is written like this. K times 2 should be written like this. So we may apply Miller-Robinson concept for a to the power m. This should be powered, that means this should be multiplied by 2. at k times. K time means it starts from 0 to k minus 1. So this is the logic. So what is the minimum a value I want to take? So you can take a minimum a value as 2. So you try a value as 2. So you calculate 2 power m. If it is satisfied, okay, you stop the procedure and display it as m. Otherwise, you repeat this process for k times. So this is the overview idea of Miller-Robinson algorithm. So let us take the steps. So I want to find out n is prime or not. So n minus 1 can be written as 2 power k into m. Here n minus 1 is an even number. Then we can able to select a random integer value a. So that a value should be from 1 to n minus 1. Then you calculate a power m mod n. Because n minus 1 can be rewritten as 2 power k into m. So I am calculating a power m mod n. That will give the remainder as b. Then check the b value. If the b value is 1, return the n is prime. Otherwise, you repeat the process k times. So k time means I value starting from 0 to k minus 1. Then you check the value whether b is returning minus 1. If it is written minus 1, then it is prime. Otherwise, you should do square operation, b squared mod n. So this is the way. So this will be taken as b means we should do b squared. And then again you check it out whether it reaches minus 1. If it not reaches minus 1, then you do the square root again, square again. So in this way you should report here. So up to k times, if the b value is not written minus 1, then the number is composite. So this is the overview of Miller-Robinson algorithm. Let us take an example. So we already know that 27 is not prime, and I want to check 27 is not prime in a Miller-Robinson technique. So I am taking base value a as 2. Always we may able to take base value a as 2. Here the given n value is 27. So n minus 1 is 26. It will be written as 2 into 13. That means 2 power 1 into 13. So it is the generalized way a power k into m. So here a value is 2, k value is 1 and m value is 13. So you should do the generalized operation. So b is equal to a power m mod n. So you calculate that procedure. So it will not return the value. You should do the I value procedure from 0 to k minus 1. So k minus 1 will give 0. So 0 to 0, the loop will not implemented. So you only calculate b power m mod n. The value is 11. It is not 1. So the number is composite. I want to check 61 is prime or not. So n is equal to 61. I am taking a value is 2. N minus 1 means 60. 60 can be written as 4 15s are 60. So 2 squared into 50. It's not necessary to split that 15 into 3 into 5. So the only condition is m should be an odd number. That's all. Odd number into 2 power k. In this format only you should write it. So here k value is 2, a value is 2, m value is 15. So first time I want to calculate b is equal to a power m mod n. So 2 power 15 mod 61, the number is 11. So you should repeat the process from k is I is equal to 0, I is equal to 1. So up to 2 times you should repeat the procedure. So 0 to k minus 1. So first time I calculated b squared mod n. b means 11. So 11 squared mod 61 written minus 1. So if the b value is minus 1, you stop the procedure and display it as prime. So in this way, you can be able to implement Miller-Robinson algorithm. So these are all the exercise values. So you implement the same Miller-Robinson testing for finding 561 or 271 or 341 are prime or not by using this technique. Let us discuss the next concept, public key crypto system model in next session. Thank you.